Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, it's so nice to see you here for Math Wednesday. It is June 1st, the first day of hurricane season. For those of you who don't live in Florida, that's what we celebrate on June 1st, the first day of hurricane season. So welcome. I'm so glad you're choosing to spend your Wednesday night with me. I know during the summer, a lot of people start to really study and get ready for those exams that they're prepping for. So I am happy to be here and be your support person and your cheerleader. So before we get started, let me know in the comment box your name, where you're from. Your name is already going to show up. Sorry, there's a lot going on. Let me know where you're from, what test you're prepping for, and are you more afraid of hurricanes or volcanoes? I don't know. It's the first day of hurricane season, so I figured why not talk about hurricanes or volcanoes. I would say volcanoes because I've lived through plenty of hurricanes. But if you haven't lived through a hurricane, that could be really scary. So I would understand that. My dog would probably say hurricanes because he does not like the rain or the thunder. He is terrified of it. So, anyways, I'm from Central Florida. I'm a math coach in Central Florida. Sorry, my nephew is making my son a bottle. So yes, that's good. Take it out and put the green top on it with the straw and then twist it on. It's a whole adventure here. My mom is watching my son and my nephew is making the bottle with the baby Brezza. So welcome to my home, guys. All right. As I'm working out these problems, let me know if you have questions. I'm more than happy to answer any questions you have in the comments. I will be monitoring the comments as I'm solving these problems. Also, if you think of something that you want me to solve next week, let me know. A lot of the problems that I'm doing are coming from people's requests, and I'm more than happy to add it in because it helps you more because I know what you need help with. So let's get started with the first problem. This is let's make the screen a little bigger. Hey, Joseph. Hey, Lynn. Hey, Tanika. Hey, Joan. So this is a 6 through 12. Screw it on the bottle. Put the green thing in the bottle and then screw the lid on the bottle. Put the green thing in first. Sorry. And then screw the top on. Perfect. Good job, buddy. All right. Use any method to find the unique solution to the system of equations. So a system of equations is a group of equations. This is a 6 through 12, 7 through 12 problem. However, I promise there is something for everybody tonight. And I like to know what test you're studying for so I really know who's in the room. But it also helps me guide the rabbit trail conversations we're going to have. So I usually try to pull at least one good tidbit in for everybody when I'm solving each problem. All right. Use any method to find the unique solution. So a system of equations is just a set of equations. So we see RMTM equals 200, RP equals 5 times RM, RPTP equals 500. That sounds like a Star Wars character. And TP equals 3 minus TM. Now, the first thought that I have when I'm going to solve this problem is I'm going to use substitution. Again, this problem is way above a lot of our friends' content limits, and that's okay. I promise we're going to get to some easier stuff in a minute. So this is definitely a substitution problem in my head. So I'm going to sit here and look and see what can I substitute. So I see that I have RP equals this, and I see that I have TP equals this. So I'm going to try to figure out what I can substitute. Another thing I'm going to do is set all of these equations equal. So if I divide in this equation both sides by TM, I get RM equals 200 divided by TM. And I'm going to do that for every equation really super fast, just so I can see all of the possibilities that I have to substitute. So I could also divide it by RM, and I would get TM equals 200 divided by RM. Again, I'm speaking a foreign language for some of you, and that's okay. We have RP equals that. We also have RP equals 500 divided by TP. I could also flip that. And now I'm going to look for something to substitute out. Now, this is going to take a hot second because I'm going to have to substitute multiple things, and then it's still going to make me do multiple steps. So I'm actually going to stop here because, yes, could I sit here and substitute? Absolutely. But what they're saying here is they've got all the answer choices outlined for us. So they're saying if I have RM equals 100 and TM equals 2, I could easily just substitute that in and see if I get a correct answer. So if I put 100 in for RM and 2 for TM, does 200 equal 200? Yes. So that checks out. I'm also going to check this. RP is 500, TP is 1. So I'm going to look for something that has RP and TP. So RP is 500, TP is 1. Does 500 equal 500? Yes, I've found my answer without doing any crazy substitution. I'm always going to look to see if I have an opportunity to use my answer choices for problems like this. I'm going to go through each of the other answer choices super fast just to show you why they don't work. So RMTM, 503. Well, if I plug in 500 here and 3 here, 500 times 3 is not 200. So that one checks out automatically. RMTM is 201. So if I plug in 200 here and 1 here, 200 equals 200. However, that one does check out. But if I plug in 500 for RP and 2 for TP, I get 1,000, not 500. So this one does not check out. Letter D, 201, we already know that that's going to check out because we already checked that. But then RPTP is 100 and 0. Well, 100 times 0 is 0, and that does not check out. So there's literally only one option that's going to work in this problem. And like I said, using those answer choices for anybody in this room, it doesn't matter who you are, when you get stuck, using your answer choices is always, always, always a good option if it's a situation like this, especially. All right, let's keep going. I love these kinds of problems. This is middle school, high school, Praxis core, GK. Depending on who you are, it could leak down into like a 6th grade, K6. You would have to look to see if volume is one of your benchmarks or standards. So Stephen has a wooden box that he wants to fill with cubes that are 1/4 inch wide. This comes directly from a request. The box is 4 inches wide, 1 foot long, and 3 inches tall. How many cubes can Steve fit inside the box? Hey, Hope. Hey, Mariella, you said FTCE math, but FTCE is a broad term for any of the exams that the state of Florida offers. So exactly which exam are you taking? Are you taking K6, middle school, high school, GK? Which one are you taking? Hey, Hart. Hey, Lynn. All right. So we have a wooden box that we want to fill with cubes. So we know we're looking for volume because we're filling up the box. So I'm going to draw a box here really quickly. Like I said, this is a great problem for anybody in the room. Okay, and he's filling the box with cubes that are 1/4 inch wide. So this is what I'm filling my box with. The box is 4 inches wide, 1 foot long, and 3 inches tall. How many cubes can he fit in the box? Here's what I want you to understand, and I'm going to go like this for a minute just because I want us to be able to see all of the answer choices. Here's what I want you to understand. They gave us 2 different dimensions. So if I were to find the volume just using a 3, a 4, and a 1, and I multiplied those together, I would get the wrong volume because this is 4 inches, this is 3 inches, and this is 1 foot. Got to pay attention to those conversion factors. So the first thing I'm going to do is transfer that foot into inches. Anytime there's a conversion, I'm going to 90% of the time try to convert it on the front end of the problem when it's all linear measurements. If I try to convert when it's area or volume, I'm going to have to do a scale factor, which is a totally different subject for another day. And if that's something you want to see, let me know in the comments. But if I have to do a scale factor, it's going to be totally different. So I'm going to transfer this foot into inches. I know 1 foot equals 12 inches. Now I can go ahead and think about what my volume is going to be. If I find my volume, I know that volume equals area of my base times the height of my prism. That's the volume of a prism. Now, some of you are saying, wait a minute. I thought volume equaled length times width times height. For a rectangular prism, you're absolutely right. And unfortunately, when we were in school, a lot of times this is what we were told volume is, and we were never taught anything else. The reason that's a volume is because length times width is the area of a rectangle, which is the area of your base times your height. However, if we are given a prism that looks something like this, then we can't do length times width times height. We have to find the area of our base and multiply it times our height. Now, here's the other thing I want you to keep in mind. Height does not have to be how tall it is. In a rectangular prism, it doesn't matter. In a rectangular prism, it doesn't matter if this is length, this is width, or this is height, or whatever. However, when I'm finding the area of a pentagonal prism, I can't do length times width times height. I have to find the area of that base and then do the height. Well, a lot of times people assume that this measurement right here, let me change colors, is your height. Well, that's because that's how tall the shape is because of the way it's oriented. But height is the distance between your two bases. So this is actually your height. This goes right back to this famous barn problem that is on the FTCE website for the GK. And that's one of the most common mistakes is people, because it's a barn, people are like, oh, how tall is the barn? That must be the height. And that's not the height. The height is the distance between your two bases. All right, let's go back to our problem. So volume is length times width times height. So if I do 3 times 4 times 12, I get 12 times 12, which is 144. However, that is not the answer because we are not filling the box with 1-inch cubes. We are filling the box with 1/4-inch cubes. That means, and I'm going to super zoom here, that means that this side is this side is 1/4 of an inch, this side is 1/4 of an inch, and this side is 1/4 of an inch because it's a cube. So because we know this is a cube and each of those are 1/4 inches, I can now go back to my shape and think about what this is going to look like. If I cut this into inches, so 1, 2, 3, 4, and I lay a 1/4-inch cube in there, I think about those like little tiny cubes that we use in the elementary school. I'm going to be able to fit 1, 2, 3, 4 right here. And then I'm going to be able to fit 4 right here. And then I'm going to be able to fit 4 right here because they're 1/4 inches. So for every inch, I can fit 4 across. For every inch, I can fit 3 tall. So how many cubes am I fitting across? Instead of 4 inches, I could say this is 16 cubes. Instead of 3 inches, I could say this is 12 cubes because they're quarters, so I can multiply by 4. Instead of 12 inches, I could say this is 48 cubes. Now, what can I do? Now I can take out my handy dandy calculator and multiply 48 times 16 times 12. And that gives me 9,216. Now, here's a test taking tip for everybody. Once I figured out that 144 was the wrong answer, I probably would have stopped right there and circled this as my answer. Why? Because I know that 1/4-inch cubes are small. They're teeny tiny. And so I know that there's going to be more than 144 cubes in my box, which tells me this is the only viable answer because it's the only answer that's bigger than 144. That's why your answer choices are so critical because you could have saved all of that time. And that's valuable for when you get to problems that are a little bit more difficult. So like I said, if I had discovered that my volume of my shape was 144, but I knew that I needed more cubes than that, I just would have gone with the only answer that's bigger. Now, unfortunately, if we had more than one answer that was bigger, we would have to go ahead and solve it. But in this case, there wasn't. For question 1, do you plug in to substitute? I was plugging in my answer choices to substitute, yes, but I decided not to use substitution property with manipulating the equations because it was just going to take too long and my answer choices were beautiful and they were helpful. All right. If the function 2x plus 3y equals 9 was graphed on an xy coordinate plane, which point on the line would fall below the x-axis? So let's just consider what they're asking here. If I have an xy coordinate plane and I'm looking for a point on the line that would fall below the x-axis, I'm looking for a point that's somewhere down here, which means my y value has to be what? Negative. If my point is falling below the x-axis, that means that my y value has to be negative. So that said, I can cross off A and B already because they have positive y values, and it does not matter if those are on this line. They're not falling under the constraints of this problem. Now, this problem is good for anybody really, because everybody needs to understand coordinate points and where they fall on the coordinate graph. It's a matter of how we use them in what you're going to see on your exam. So we have 5, -1. So 5, -1 might be around there. And we have 9, -3, which might be like around here. So now we need to figure out which one of those points is on the graph. Now, I could solve this 2 ways. I can graph it, and then figure out what line is on, or which point is on the line, or I can just plug these values into my XY coordinate plane and see which one works. If I graph it, I'd have to put it into slope-intercept form because this is standard form, and standard form really is not that helpful. Gary, I see your question. I'll answer it in a minute. Standard form is really not that helpful when we're graphing lines. Slope-intercept form or point-slope form is way more helpful. So if we look at slope-intercept form, I'm just going to show it to you really quickly because everybody needs to know it. Slope-intercept form is y equals mx plus b. Point-slope form is y minus y1 equals m times x minus x1. Now, those are called point-slope form and slope-intercept form because mathematicians are not creative when they name things. This is a slope. This is your y-intercept, hence the slope-intercept. This is a point, and this is a slope, hence the point-slope form. So I can put this equation into that form. So 2x plus 3y equals 9. In order to get that into slope-intercept form, I'm going to get y by itself. I'm going to isolate that y. So I'm going to subtract 2x from both sides. And I have 3y equals -2x plus 9. Why did I put the 2x in the front? Because it's in the front in my slope-intercept form. Elementary people, I hope you're paying attention to how I'm manipulating this equation because you need to know this. I'm going to divide both sides by 3. So y equals -2/3 x plus 3. Now I can graph it. This is my y-intercept. So I'm going to go up 3, 1, 2, 3, and put a point because it's my y-intercept. And I'm going to go down 2 and over 3. Down 2 over 3. Down 2 over 3, and then I have my line. Now, if I didn't graph it accurately, I could get the wrong answer. You've noticed how long this has taken me. So like I said, I wanted to show you how to graph it just because it's important for everybody to know, but I'm just going to take this x and this y and plug it in. 2 times 5 because the x comes first and then the y. Plus 3 times -1 equals 9. 10 plus -3 equals 9. 7 does not equal 9, so C is out. I am going to solve D just to make sure I'm correct and I didn't make a silly error somewhere. So 2 times 9 plus 3 times -3 equals 9. 18 minus 9 equals 9. That does check out, so D is the correct answer. For this problem, could you divide the total volume of the box by the volume of each cube, correct? Divide the box volume by the cube volume. Sorry, I'm trying to see if that would work. So, yes, I got 9,230. The answer is 9,216. That could also be because I rounded off the decimal. So, yes, to answer your question. All right. A ball, but that also goes back to that whole scale factor conversation that we can talk about next week if you want. A ball is thrown. Okay, so this is another middle school through high school, because my GK people, you do have quadratics in your blueprint. Now, quadratics is a tricky one because the state sample test doesn't have a whole lot of quadratics, but it is listed in the blueprint or the standards. So it's just something you want to keep in mind. A ball is thrown up from the top of a building and is represented by the function h of t equals negative 16t squared plus 5t minus 34. Which of the following values, so we're not actually solving something, represents the time at which the ball hits the ground? This is a super fun question. So here's what we're going to do. We're going to draw our picture. So I've got a coordinate graph, and I really gave myself way more room in the first quadrant than I did in the second, third, and fourth. Here's why. Because while this is a parabola that's going to go down, why is it going down? Because of this negative value right here. If there's a negative in front of the t squared or the x squared or whatever your variable is, it's an upside down parabola. If it's a positive value, it's a right side up parabola, no matter what the other symbols are in the equation. So we know this is an upside down parabola, but it doesn't matter what the parabola is doing over here or down here, because I'm not going to have a negative height and I'm not going to have negative seconds. So I know that my x-axis is being represented by t. This is my x-axis, but it's the time factor as evidenced by the t's being in the equation. And my y-axis is my height, because the height is dependent upon the time. So they throw the ball up, and then it comes down and hits the ground. Now, is that an exact picture of what this parabola looks like? Probably not. Does it matter? Absolutely not, because they didn't ask us to find the actual value. I threw the ball up from the top of a building, it hit its height, and then it came back down. So when we look at this parabola, and I dotted lined that because I'm not going to have negative time. So when I look at this, which of the following values is when the ball hits the ground? Well, the ball hitting the ground is a value of h equals 0. Where does my height equal 0? My height equals 0 right here, or anywhere on this x-axis. Where does time equal 0? Time equals 0 right here or anywhere on the y-axis. So when my height is 0, I'm looking at my x-intercept. When my time is 0, what am I looking at? My y-intercept. Time equals 0 is your y-intercept, or your starting point. The y-coordinate of the vertex. Let's look at what that value is, because I want you guys to understand what all these values are. So my vertex is going to be the maximum height, and the y-coordinate of that is going to be the maximum height because the y is the height. So the y coordinate is the maximum height of this parabola. What if they said the x coordinate of the vertex? That would be the time the ball hit the maximum value. An axis of symmetry is where that parabola can be folded in half, because symmetry is when something is the same on both sides. And the axis of symmetry is also the maximum height of the ball. So all that said, which of the values represents when the ball hits the ground? The x-intercept. All right, let's move on to a K through 6 problem. I pulled this straight from our K through 6 curriculum and changed a couple of things around. So my K through 6 people, this problem is for you. Does that mean everybody else doesn't need to pay attention? Not at all, because we can all learn something from every problem. All right, Amelia makes blankets. She can make 8 blankets with 32 yards of material. How many yards of material would be required to make 22 blankets? Now, this is one of those problems where you wish you could just do it in your head, because I'm immediately thinking 8 blankets equals 32 yards. How many yards are required for 1 blanket? Well, if I have 1 blanket, that would equal how many yards? If I divide this side by 8, I can divide this side by 8, and that would equal 4 yards for 1 blanket. Now I can kind of take that information and figure out how many yards of material it would require to make 22 blankets. So if I have 22 blankets, and I know it takes 4 yards for 1 blanket, I can multiply the 22 times 4, and I get 88 yards of material. Could I also set up a proportion? Let's find out. If I do blankets to yards equals blankets to yards, we can go ahead and set up that proportion. So if I have 8 blankets and it takes 32 yards of material, and then I know I want to make 22 blankets, and I want to know how many yards it would take to make that, I can set up a proportion, and then I can cross multiply. 8x equals 32 times 22, which is 704. Divide both sides by 8, and x still equals 88 yards. So 2 different ways we can solve it. Both work. This is how I actually set up my conversions when I'm looking at conversions that I don't quite understand. And that's how it helps me to convert values that I may not understand. All right, we are rolling through some problems tonight. Problem 6. This is good for everybody. The science test scores for 6 of the 7 students in Mr. Morrow's math class are shown below. If the average score of the test was 82% for, it said her, but this is a Mr., so for his entire class, what was the 6th student's score? So we have some values here, and what do those values represent? Those values represent the test scores for 6 kids. And they've given us the average. So if the average score was 82%, and we have to find the 7th student's score, not the 6th. You can tell I changed some things in this problem. 7th. So how am I going to figure this out? Well, I'm going to first think about what average means. Average equals the sum of all your data points divided by the number of data points. Average equals the sum of your data points divided by the number of data points. That's also known as your mean. It's known as your mean because it's very mean because it makes you do a lot of work. Other modes of central tendency are mean, median. I don't understand why it does that sometimes. It has something to do with where I rest my hand on my screen, and I haven't quite figured out where that is. So we have mean, median, mode, and range. So mean, median, mode, and range. Those are different measures of central tendency. Median is the middle of your data when you put it in order, because I think of like the median of a road. Mode is the one you see the most, hence mode, most. Mean is really mean and it makes you do a lot of work, and range is the difference between your highest and your lowest. So if I'm going to add all of these up, divide it by the number, it should equal 82, except I'm missing a 7th student's score, but the average with that student's score is 82. So take a look. 87 plus 84 plus 91 plus 75 plus 74 plus 94 plus X. X is your 7th student's score. Divided by how many data points do I have? I have 7 data points technically, because I have 1, 2, 3, 4, 5, 6, but that X is 7 because it's included in my sum. All of that is going to equal 82. Now I'm going to go ahead and add those together, and I'm going to do it twice. Why am I going to do it twice? Because when I add that many numbers together, I very easily could have a slip of the finger. So 75, 74, 94. I got 505. I'm going to check my work one more time. 87, 84, 91, 75, 74, 94, 505. So 505 plus X divided by 7 equals 82. Now, really, my goal is to just isolate that X and get it by itself so I can figure out what that 7th student score is. How am I going to isolate that X? Well, right now, X is in numerator jail. I can't do anything with it. So I have to undo what's being done to it. When I undo what's being done to it, I'm going to multiply both sides by 7. Why am I multiplying both sides by 7? That's a great question. Because that numerator is being divided by 7. And to undo division, I multiply. So when I'm looking at ways to undo operations, I can undo addition with subtraction and vice versa. I can undo multiplication with division. I can undo a square root with a square value. So I'm going to multiply both sides by 7. 82 times 7 equals 574. 505 plus X equals 574. And now I can just subtract. Subtract 505 from both sides. And X equals 69. So that 7th student got a 69 for the average to be an 82. All righty. Let's take a look at this one real quick. James is 3 times older than 2 less the age of his sister Penelope. Which expression represents Penelope's age? So we talked about this last week when we were doing the length and the width problem, because we were looking at what words mean when we translate them into expressions. So when I translate this into an expression, I'm going to take it word for word. James is. I'm going to define J as James, and I'm going to define P as Penelope. So James is. Is usually means equals when we're working with an expression like this. 3 times older than what? Than all of this. My throat just got really scratchy for some reason, and I don't know why. James is 3 times older than 2 less the age of his sister Penelope. So 3 times older than that entire section. Understanding how to translate these equations is really important. So James is 3 times older than what? 2 less the age of his sister Penelope. Do not get tricked by doing 2 less than Penelope. Subtraction is not commutative, which means it cannot be flipped around. Addition and multiplication are commutative. 3 plus 5 is the same thing as 5 plus 3. 3 times 5 is the same thing as 5 times 3. However, subtraction does not work like that, so we have to really understand what this means. If I said, what is 8 less than 10? What would you tell me? You would tell me 2. 8 less than 10 is 2. Well, how did you get that? You did 10 minus 8. So 8 less than actually means something minus 8. 2 less than means something minus 2. And what is that something? That something is P. So what we're actually looking at is James equals 3 times P minus 2. But they didn't ask for which expression represents James's age. They asked for which expression represents Penelope's age. So this does not represent Penelope's age. If we solved that, we would get James's age. Let's keep solving it for P, because if we're looking for an expression that represents Penelope, we're looking for P equals. So now I have to manipulate this equation. I'm going to divide both sides by 3. So I have J divided by 3 equals P minus 2. Add 2 to both sides. And we see that B is the answer. All right, I had a question on the last problem that I just did. What is the mode of a list that doesn't have a repeating number? That's a great question. So let's go ahead and make up a set of data. Actually, we have a set of data. So those test scores, let's take those test scores. 87, 84, 91, 75, 74, 94, and then we solved for 69. So what would the mode be of this data? You could say that it doesn't exist. Some will say it doesn't exist, and some would say all of these numbers are the mode because they all show up the same amount of times. So it depends on, they won't have both of those answers because then they would both be correct. So the mode of this data could be none, or it could be every single one of those data points. To find the median, we would put them in order. So 69, 74, 75, 84, 87, 91, and 94. And then we would just cross numbers off to find that median. So 1, 1, 2, 2, 3, 3, and your median would be 84. Excellent question. Remember, as I'm solving these problems, Don't forget to ask me questions. And if there's something you have not seen tonight that you really wanted to see, don't hesitate to reach out to me on Facebook, Amy Sink, or comment on our group Facebook page, or just let me know in the comments tonight what you want to see next week. Would 69 be considered an outlier? No, because you have 74 and 75 really close in there. And there's a special equation that you can use to find outliers. It has to be a certain percentage away from the rest of the data, but that's definitely not an outlier. All right, let's do translation problems. So a triangle has points A, -3, 2, B, -1, 1, and C, -2, 6. If the shape is rotated 90 degrees counterclockwise about the origin, what would the coordinates of A prime be? Let's first understand that A prime is just the new coordinate. So I'm going to quickly sketch a graph of it just so that we can see it. We have -3. I'm going to try to do this as accurately as possible, and you'll see why in a minute. Okay, -3, 2 is like right here. -1, 1 is like right here. And -2, 6 is right here. So here's my triangle. Okay. And we're rotating it 90 degrees counterclockwise. So we're going this way about the origin. Now, there are some very calculated ways that you can find translations. I don't have these memorized, so I'm just going to pull them up. You should have these memorized if you are taking this exam. I once had these memorized. I don't use them every day, so I don't. So a 90-degree rotation counterclockwise will take your XY, your original XY, and it'll turn it into -y, x. A 180-degree rotation will take your normal XY, and it'll turn it into -x, y. And a 270-degree rotation will take your original point, and it'll turn into y, -x. So if I'm taking point A, -3, 2, and I'm rotating it 90 degrees, I'm literally going to flip my x and my y. So it's going to turn into 2, -3. And then my y is going to turn into a negative. -2, -3. So D. So I'm going to go ahead and plot that. -2, -3. And I'm going to do that for all of them. -1, -1. And -6, -2. So this is what my new shape would look like. Now, I'm going to get real fancy with you. If I were to draw a circle around the origin, this was A, this was B, no. This was A, this was B, and this was C. This was A. If I were to draw a circle that was centered around the origin, you would see the points hitting that. The points of the first triangle literally rotate around and hit the circle on the second triangle. And that's what's happening when we're rotating. It would happen when I'm rotating 270 degrees or 180 degrees and then 270 degrees as well. So now, rotating about the origin is probably the easiest rotation there is. Let's now rotate about a point that's not the origin. So I have my same picture here. I'm going to erase a little bit of this and just copy and paste it and bring it over with us. So we're going to copy this and paste it right there. Okay, so here's our original triangle. If the shape was rotated 90 degrees around the point -2, +2, what would the coordinates of A prime be? This one gets tricky. Now, when we are rotating around a point that is not the origin, here's your steps. 1, subtract the point of rotation from your original coordinates. 2, rotate as usual, like you would around the origin. Number 3, add the point of rotation back in. Now, let's take this and do it. So I'm only going to do this with point A. Why? Because point A is the only one they're asking for. So I'm going to take point A, -3, 2, and I'm going to subtract this from my original. So I'm going to subtract -2 and 2. -3 minus -2 becomes a positive. So that actually equals -1. 2 minus 2 equals 0. Now I'm going to rotate as usual using the rotation rules from here. So it becomes -y, x. So I'm going to -y, well, 0 can't be negative, so 0, and then x. The x doesn't change. Then I'm going to add this back in. So I have 0, -1. I'm going to add -2 and 2. 0 plus -2 is -2. -1 plus 2 is 1. And I made a typo, so it's -2, 1. And that was just a typo on my end. So that's our answer. All right, I would like for you to go over SOHCAHTOA problem with the Pythagorean theorem, where you're given one angle and you need to find a side, or a given side and you need to find an angle. Okay, I will absolutely go over that next week. That's an excellent question. I'm going to take a picture of that so I don't forget. Why did I subtract on problem 10? I haven't done a problem 10 yet, so I'm not really sure what you're asking me. All right, we have time for one more problem. So let's go ahead and do this problem. This is coming straight from like an elementary GK. Like it's kind of like all in that area. Why did I subtract on problem 10? Are you talking about why did I subtract on problem 7, this one? I'm not sure what you're asking me. I'm sorry. Okay, the price of a pack of hamburgers is $24. And the price of a package of hot dogs is $18. A wholesale store has a promotion that offers a 15% discount on a package of hot dogs when 2 packs of hamburgers is purchased. What is the total cost of 3 packs of hamburgers and a package of hot dogs? So here's what we need to understand. They're asking us for 3 hamburgers and hot dogs. The most common mistake is going to be people only doing 2 packs of hot dogs, because they told us that you're getting a 15% discount on a package of hot dogs when you buy 2 hamburgers. So you have to at least buy 2 hamburgers. So I know that I want 3 packs of hamburgers, and I'm not getting a discount on the hamburgers. So I know that I'm going to do 24 plus 24 plus 24. And that's going to equal, I am going to use my calculator because my brain is dead. 24 times 3, 72. But then I also need to add my hot dog. But I'm going to have to figure out my discount. So I can do one of two things. I can do 18 times 0.15 and then subtract that value from 18. So 18 times 0.15, because I transferred this into a decimal, equals $2.70. Now, that is not what I'm paying, y'all. That's the discount. So now I can subtract $2.70 from 18. And I get $15.30. Or I can do 18 times 0.85, because 0.85 is the remainder part that I'm actually paying. It's the percentage that I'm paying, not the percentage of the discount. Still equals $15.30. So I'm going to add $15.30 to 72. Bada bing, bada boom, $87.30. Why did I subtract and then add? Because that's the process of how we're translating this triangle. Here's why. Because what I'm actually doing is I'm subtracting the amount and really kind of shifting that shape back to the origin so that I can then rotate around the origin. So by subtracting the value of the point that I'm rotating around, what I'm really doing is shifting the triangle around back to center it back to the origin. All right. We have run out of time for today. I will definitely go over SOHCAHTOA and Pythagorean theorem next week. I will definitely go over the 3 to the x problem that you sent me. It's a bear of a problem, and it's honestly one I would probably skip on my exam if I found it, just because it requires a lot of steps, but I will go over that one next week. And if y'all have anything else you want me to go over, please let me know in the comments. I will go over some asymptotes as well, and I will see you next Wednesday. I'm going to turn it back over to Dr. A for a quick closing message.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.